All right, so this is CS50 Explained, Behind the Pedagogy, our first session of the workshop that's really meant to give you a sense, as teachers or prospective teachers, a sense of the why we, for CS50, do things the way we do, for better or for worse. Ultimately, the goal of this whole initiative for the past many years has been to really make available as open courseware curricular materials that teachers like yourselves are welcome to adopt or adapt in any way you see fit. Indeed, typically what we found is that if teachers are wanting to teach introductory computer science or programming or AP computer science principles or any number of variants thereof, they might in their first year, especially if new to teaching itself, might want to adopt some of the courses or all of the courses curriculum in some way and really serve the role more of a teaching assistant, leaning on us and our videos and our homework assignments, aka problem sets, while they walk around focusing their most precious time, the human time, on their own students. And then perhaps as they get their footing, or if you've been teaching for many years, you might instead pursue more of a model of adapting the course, like any good teacher might when seeing someone else's materials, and make it your own and integrate it into your own classes as you see fit. What I thought we'd do then this morning here in Cambridge is just give you a sense then of the why behind the course's pedagogy, and also just give you a few building blocks if you're only somewhat familiar with CS50 and its offerings, or perhaps familiar only from the perspective of being a student of sorts yourself, having taken the class. Along the way, please feel free to interject with any questions via the chat that I or any of my colleagues here can answer, or if you'd like to raise a virtual hand in Zoom, we'll do our best to keep things interactive, and then we'll take and leave time for a good break at the end, and then resume with our second session thereafter. So a cursory glance at the history behind this class, if only to give you a sense of why it combines the topics it does. Here at Harvard for the past many years, there was this branch of courses starting with Engineering Sciences 100, Applied Mathematics 110, and then finally Computer Science 150, when computer science finally became a term academically that described a whole field. But this was an evolution of a particularly arcane set of classes, if you will, particularly for those who wanted to pursue what originally was called engineering, was eventually called applied mathematics, and now, of course, is called computer science. But it was fairly technical for the particularly initiated, the already initiated. Then at Harvard, too, some years ago, there was a different branch of courses, if you will, starting with a well-known course here on campus called NatSci 110, Natural Sciences 110, which eventually evolved into a course called Applied Sciences 10, and then eventually Quantitative Reasoning 20. And this was more of a path for the uninitiated, those less comfortable, who wanted to know something about computing and programming ultimately, but didn't necessarily think they were going to major in the same. And then eventually, Harvard as a university rather started to merge these two tracks in a sense, and we had Applied Sciences 11, Computer Science 11, and now what we're here today to talk about, a course known as CS50. And that all began back in 1989, which was the first year of CS50 being offered here on campus, and it was and is our introduction to computer science and programming, but now for majors and non-majors. And that's perhaps the key characteristic, in that it does try to serve both of those audiences. And you'll see today and tomorrow via what curricular means and pedagogical means we aspire to do so. As it turns out, I myself happened to be an undergrad here some years ago, and in 1996 as a sophomore took this same class. As I tell students at the start of our own course, I was a government major at the time. I had gravitated from the get-go at college toward the familiar. I rather liked history and constitutional law, especially in high school, and so I figured, well, you major in college what you seem to like in high school. But it wasn't until sophomore year that I got up the nerve, the courage to just put my toes in the water and to step in on the first class of CS50 in September of 1996. And long story short, I was hooked. As I tell students today, it was the first course and really the first field where, not to sound too cliche, but like homework was fun. I had somehow gone 19 years of being a good student, focusing on my work, but not particularly describing school or homework as fun. But when I discovered computer science, and particularly programming for me early on, like something clicked. And as I tell students, I would go back to my dorm at like 7 p.m. on a Friday night, which is when they would officially post the homework assignments. And that's how I would spend my Friday night, well, into Saturday. And for me, that was a sign. Changed my major to computer science, and ultimately that's what's motivated now really a lot of my interest in, dare say passion for, trying to create, whether it's in computer science or any other field for students, that sort of discovery and that encouragement to explore outside one's own comfort zone. So fast forward several years later, after finishing college and then graduate school in 2007, I was rather in the right place, right time, and had an opportunity to take the helm of this same course as its instructor. I was meant to fill in for just a year, after which the course would be taught by someone else, and somehow or other that was like coming up on 16 years ago. And so this will be version 16 of the course since 2007. And nowadays, in healthy times, it's indeed one of Harvard's largest courses here on campus. So this is a photograph of one of the most beautiful spaces here on campus, Sanders Theater, so to speak, with a whole lot of students back in healthy times and me down here about to talk about computer science. And we hope, of course, to return to that kind of norm this year and beyond. But that is to say, there's been a marked increase in interest here and certainly elsewhere in the world in computer science and programming. And so really what we'll focus on today is the support structure and the pedagogy that we've tried to build up over time. The course, as I alluded to earlier, has since 2007 also been freely available as open courseware under what's called a Creative Commons license by NCSA, which means that anyone is welcome to use the material as they see fit, so long as they attribute it by CS50, so long as it's for non-commercial use, and so long as they, too, share alike their materials, be it videos or PDFs or adaptations thereof. For more details, Carter, if you wouldn't mind pasting a URL like this in the chat. Now, in 2012, it's worth noting that we had an opportunity to not just put material out there in the spirit of open courseware, but 2012 was when this MOOC craze, massive open online courses, rather begun with Coursera, then edX, and a few others as well. And this was an opportunity for us now to focus not just, of course, on our own campus students, but really anyone online who might like to learn, but learn as actively as possible. For many years, we had put our videos, our PDFs, the assignments, and so forth on the internet. But if a student elsewhere in the world online didn't have a Harvard University login account to connect to some Linux or Unix server here on campus, the onus was on them to figure out how to install a compiler, an interpreter, a debugger on their own Mac or PC. Doable, but not necessarily doable by many students who don't yet have that footing and might otherwise struggle with Hello World, let alone just trying to configure things like your path and your terminal window and the like. And so we began to focus in 2012, too, on really making tooling and software available for students and teachers alike to eliminate a lot of that complexity so that they could focus truly on the curriculum and less so on the mechanics of just getting requisite software set up. And so thus was born what we now call CS50X, which is essentially the open courseware version of the class, typically targeted at university or older students, but it is exactly the same curriculum technologically and curricularly as the course here on campus. Students, of course, on campus have access to additional support structures like human teaching assistants or TAs, as you might find in universities typically. But otherwise, curricularly, technologically, everything is exactly the same. And Carter has kindly pasted this. And Carter, if you don't mind, some of our upcoming URLs as well. CS50 has generally steered in the direction of existing online platforms for bringing people together. And so if you go to this URL here, you'll see any number of CS50's online communities, Facebook and Reddit and Stack Overflow and Discord and the like, where we've rather tried to bring the course to the students to decrease rather the transaction distance, so to speak, between them and asking and answering questions, as opposed to focusing on walled gardens or proprietary tools that might require the activation energy to come into the course. Rather, we've tried to bring folks to it. And we've also tried to focus in recent years since 2012, again, not just in putting curricular materials out there for folks to use, but trying to incubate, encourage, foster really in-person communities. It's not, the real opportunity is hand, whether with teachers formally in place or just students who want to learn together, is to try to bring them together as humans. And Zoom and other technologies have certainly accelerated this trend online, but we have also focused in healthier times, and hopefully this coming year and beyond, on helping incubate in-person communities, be it at high schools, middle schools, universities, nonprofits, community groups, or the like. And so just to paint a picture of some of your predecessors, if you will, or perhaps some of you here, here is one of our groups in healthier times at Miami-Dade College, led by one of our faculty member friends there. And these are students holding proudly their CS50 certificates, so to speak, at term's end. Here are some students in healthier times from London, when we held with University College London a so-called CS50 hackathon that drew people together to work on their code and their final projects. Here, some of our students in India working on something called CS50X Puzzle Day. More on that in a bit, bringing students together as well. Here in Myanmar was a student who actually organized this many of his classmates to teach CS50 or introductory programming more generally to some of his own classmates. Here, after a CS50X puzzle day, our students in Pakistan. Here, our students after the same in Egypt. Here, some of our students before the same in Congo about to tackle these printouts of puzzles. And here, some of our friends who have been especially in our thoughts in recent months in Ukraine as well. And these are just some of the communities that have been incubated over time. But this has, I think, been a very deliberate charge on our part, not to just put curricular materials out there, but again, to try to bring people, teachers and students alike, together in the form of these more traditional in-person support structures. You've heard me allude now to CS50 AP, which is a bit of a deliberate misnomer in that it isn't necessarily an AP or advanced placement version of the course, but really an adaptation designed for high schools and middle schools alike. Its release coincided with the creation of AP Computer Science Principles, with which some of you might be familiar here in the US or also abroad. And CS50 is one of the endorsed curriculum providers of that same framework. But CS50 AP, when we say it, really just refers to a high school or middle school, a younger audience adaptation of the same course that also happens to satisfy those requirements. But it's an offering typically that is designed to be spread over not maybe 12 or 16 weeks in a typical US semester, but maybe 32 or 36 weeks over a typical US school year. With that said, at its inception, CS50 AP here, which has, again, the same curricular materials as CS50X itself. Here's an early snapshot of all of the high schools and universities and others that were working with us at the course's debut. Every circle in red represents a high school with which we've worked in the past. Every blue represents a university. This now is several years old, but this too was an opportunity for us to try to bring people together as well. And I wish you and I were literally on that same stage right now. This is a photograph of one of our earliest cohorts of teachers at our very first CS50 Educator workshop here at Harvard. Hopefully, health circumstances permitting, we'll be able to hold this same workshop both in person and online next year. But these are some of our teachers with whom we got to meet and the original network of teachers that began via this whole initiative as well. And in healthier times, too, did we focus on the students as well. Margaret, whom you met earlier, kindly helped us coordinate with a few other teachers in New York, public and private, a CS50 hackathon. Unlike our university hackathon, which tends to start at 7 p.m. and end at 7 a.m. the next day, this was our first 10 a.m. to 2 p.m. CS50 hackathon, a little more high school and teacher and parent friendly, that just brought students together from 5 different schools in the area to work on their problem sets, to attend some stand-up workshops and the like, and generally just have fun learning and asking questions and solving problems, all within this domain here of computer science. So at the risk of overwhelming, just to give you the lay of the land, but the whole goal of today and tomorrow is to just give you a sense of what is available to you. It is not the sort of menu via which you must choose a little something of everything, but just to give you a sense of what now exists. One of the FAQs we began to receive shortly after the course launched in 2015, especially in the form of AP for high schools and middle schools, was, OK, I've taught this course now to my first years or sophomores or maybe seniors. What now, at least for those younger students? And so in recent years, have I and some of our colleagues here at Harvard begun focusing on other curricular offerings as well, all under the CS50 umbrella. And so while you've had the whirlwind tour of the history, where CS50 was the course that existed as of 1989 and ever since, now we use that same moniker with suffixes to describe other curricular offerings that assume either as background CS50 itself or assume as a next step CS50 itself. So here is the current list of all curricular offerings, CS50X, which again is the online university and adult offering of the same, CS50 AP, which is that for younger audiences. But thanks to some of our amazing colleagues here, do we now have CS50 AI, which is an introduction to artificial intelligence with Python specifically. It's indeed more software-centric than it is mathematically oriented. It introduces students to any requisite mathematics they need, but it's not a theory course as much as it is a software course. CS50B is computer science for business professionals, something for students in management school or the like who just are interested not so much in the lower level implementation details, but rather how you can leverage technology in business or just make more informed decisions. CS50G, introduction to game development, that uses a language called Lua. that allows students on their own Macs or PCs to create their own two-dimensional, and then later in the course via Unity, three-dimensional games as well. CS50L for lawyers, computer science. This is similar to CS50B, but targeted specifically at the legally minded folks out there, paralegals and the like, who want to explore the intersection of computing with law in particular, issues of security and privacy, intellectual property, and the like. There's a similar backbone among many of these courses, but their focus tends then to vary. CS50P, which is hot off the press, so to speak, an introduction to programming with Python specifically. We go all the more into detail on the syntax of Python, the features thereof. We stop short of any topics that really are, and dare say belong, in CS50, aka CS50X or CS50AP, which is a proper introduction to computer science. So while we might take for granted in CS50P that there's a function that sorts for you, it's in the original course, CS50 itself, that we actually pull the lid off of sorting and searching and algorithms and data structures more generally. So CS50P is very much focused on programming itself and is designed now to be a course that students can take before or during or after CS50 itself as either additional material or perhaps preparatory material for the same. CS50S, perhaps for your younger students or less comfortable students, is an introduction to programming with Scratch, the graphical language that we ourselves use in CS50. In just the first week of the class, this is a version of an introductory course that you might take 3 weeks, maybe even 6, with your younger or older students to go through at a slower pace, but with a higher ceiling as to what they can then do with Scratch itself. CS50T is an introduction to understanding technology. So it's similar to CS50B, the business class, similar to CS50L, the law class, but it focuses more on consumer-type technologies, how the internet works, how your own Mac or PC works, and uses some of the shared backbone, but focuses really on folks who aren't necessarily business or law-centric, but more generally using technology. And then lastly, but not least, is CS50W, a course on web programming with Python and JavaScript that's meant to, like many of these, pick up where CS50 leaves off and be a second course, be it for students in high school or university or folks in the real world, to dive in more deeply into web programming specifically, assuming as prior knowledge CS50 or some similar course as well. Carter, I think no need to copy and paste all of these links, but if you have the URL of these slides, which maybe, Carter, it would make sense to paste the URL of this slide into the chat, you're welcome to click on each and every one of these links, which will lead you to the free OpenCourseWare curriculum of all of these same courses in one place. And I'll note here that characterizing all of these classes, but especially the original class, CS50 itself, are really these two themes. And in fact, after 1 or 2 or 3 years of teaching, I began to reflect on what I was actually doing and why. I dare say that first year of the course, second year of the course, I was just focused on keeping my head above water. And it's only in recent years that I've really noticed themes in my own approaches, for better or for worse, to teaching the class. And I dare say 2 of them are really this: accessibility and rigor, sort of lowering the floor, so to speak, metaphorically, for students to make it easier for them, similar in spirit to what I hoped to do back in 1996, just put a foot in the door and get some exposure to CS. But simultaneously preserving what, at least here on campus, has been a historical rigor, so that the returns, so to speak, of taking this course are especially high for students. And it's a particularly immersive, it's a particularly intensive experience, but hopefully are the returns all the more proportional as well. And so I dare say students taking this course, CS50, off campus, be it online or locally elsewhere or through high school, where you don't have the constraints temporally of 12 or just 16 weeks, but you indeed have 32 weeks at your disposal, maybe even 52 weeks in total. That, I think, is indeed the enabling technology. This isn't a Harvard course per se. We are just confined by the traditional model of a semester. I think really the key ingredient for students of any academic or curricular background is just to allow themselves sufficient time. And so that's a knob that we generally recommend folks turn, rather than jettisoning material or making things easier and chipping away, therefore, at these primitives. The second one, of rigor in particular, just allowing and structuring perhaps your own classes to just give students more time. Instead of 1 week for a given problem set or homework assignment, perhaps 2 or even 3. And as Margaret might address in her experience, and our friend Douglas tomorrow speak to their own experience with turning these knobs and adapting the material as they see fit, as might be best for their own students. This, too, was a key curricular design early on, here on campus at least, where we had within the same class, CS50, different tracks, so to speak. We, like a lot of universities, have a model where we have weekly lectures. So I will lecture once a week to all of the students in the class, presenting the week's concepts and really setting the stage for the week's assignment. But our teaching assistants, who are typically undergraduates themselves who've taken the class, and perhaps others in CS, they then lead sections or recitations for maybe 12 to 20 or 30 students in total, generally on campus, but for our online extension school students or adults through continuing education via Zoom as well. But we've typically on campus had different tracks of these sections or recitations for those more comfortable, those less comfortable, and those somewhere in between. And we just ask students to categorize themselves at the start of the semester. And we tell them, you're more comfortable if you've been, in fact, programming since you were 6 years old or the like, but maybe you don't have a formal background in CS or programming, and that's why you're nonetheless taking a formal introduction there too. You're among those less comfortable if, like me in 1995, you didn't even consider taking the class, or you have one foot in the door and the other one still out the door because you're not sure if computer science or programming is for you. And if you're not really sure where you fall, we assure students that they're just somewhere in between. So we have 3 different tracks that generally offer students the same introduction to computer science, but at a different pace. And the teaching assistant leading these tracks might speak to students at a different level, allow the conversations, perhaps if more comfortable, to go all the more down a detailed rabbit hole, or at least pumping the brakes, perhaps, for those less comfortable to make sure everyone is comfortable on the same page. I'll note, though, that in recent years, as the course has grown in size and as the demographics of our student body have changed, we were actually motivated this past year to introduce a 4th track, if you will, for those euphemistically least comfortable, who really need some additional support, not just with taking the class itself, but perhaps just with college. Perhaps they didn't have the strongest high school or middle school background. They don't necessarily have the instincts, or they didn't have the high school that trained them to take advantage of the online resources and the professor's office hours and the like. And so in this particular track for our university students, do we also just help them structure their days, structure their time so as to be successful in college? Because CS50 here on campus has actually gotten younger over the years. We used to have a plurality of sophomore, second-year students, but over the years, students have started taking the course more and more as first years, which means ours is the first of maybe 4 classes they might take ever in college. And so the onus has come to us to be all the more supportive of them just getting their footing on campus. It's also been important, if you know CS50's curriculum, that we introduce, in my mind, different languages to students. Back in the day, in 1996, when I took the class, it was a course in C. And the vernacular on campus was, I know how to program in C, because I took a course in C. We eventually introduced, though, other languages into the same course. And nowadays, we start with 1 week of Scratch. We then have several weeks of C, which is still the backbone of the course's introduction to programming. And then we have a few weeks of Python. Added to that, some SQL and JavaScript, and the requisite HTML and CSS, so that for many students, CS50 is designed to be either a foundation in computer science for further studies in a traditional way, but also a terminal class for about half of our students, whereby we know a priori that half of our students are not going to take another CS or programming class, and we want them to have not just that foundational mental model for solving problems with technology, but also the practical skills to bring back to the arts, the humanities, the social sciences, or the like, so as to solve real-world problems, even with just a semester of computer science under their belt. And so our goal with these various languages and the intensity of the course is so that students exit the class with the mental model of, I learned how to program, period, as opposed to, back in my day, what would have been, I learned how to program in C. To be fair, we focus on procedural programming. It's in other courses that students here at Harvard tend to learn a bit more object-oriented programming, functional programming, although we touch on, briefly, some of those topics. We hint at them when we introduce languages like Python and JavaScript, which lend themselves to some of those chats. So I thought it might be fun or helpful, perhaps, to share a few vignettes of curricular content from the course itself. Some of you might recognize these scenes or similar. I took a few screenshots or photos from our lectures 2 years ago. To be fair, I should qualify this as this was the first year of COVID in fall of 2020. Everything here on campus was shut down and almost everyone was therefore online except us. We had this wonderful silver lining opportunity to collaborate with a theater here on campus whose staff was otherwise idled. And so what you're about to see is admittedly a grand implementation of visions that I've had for 15, 20 years as a teacher. But when it turns out when you have a prop shop behind you in the theater and talented artisans who can build things out of wood and electricity and the like, you'll see some examples of curriculum that we brought to life. But every one of these examples have I done in yesteryear using a scrap of paper that I brought with me or a Sharpie on the board or the like. There are lower budget versions of each of these demonstrations as well. But the goal really of each of these vignettes is to paint a picture of like why in CS50 we, or I personally, spend so much time teaching something like linear search, which maybe we could get away with just a few minutes of a description, maybe a drawing on the board or a few slides. But instead, we might spend 15 or 20 minutes inviting students in healthy times up to the front of the class to demonstrate something with me, bringing in props and creating all the more visuals. The goal in my mind, just as a teacher, is to not just get through the course's curriculum and say the words or the topics that we want students to learn, but to create these memorable moments, spending perhaps an unusual amount of time to create those things they can latch onto mentally, even for years, that help them orient some arcane topic in the practicality that it actually offers. So you might recognize something like this. I, at least, have been a fan since 2007 of talking about binary using lights. Back in the day, I used some desk lamps that I found from IKEA. Nowadays, I might have a few students come up and turn on the light bulbs on their phone. Turns out when you're in a proper theater, you might have dozens of light bulbs right in front of you, literally, on the stage. And so here is an opportunity where I introduce students each year to the concept of binary, but really representation of information, but rather bringing it to life visually by turning and turning off light bulbs. A goal I had had for 14 years, that first year of COVID when we were in this theater, was to actually do searching with physical doors, to be able to walk up to it, open the door, and look for something behind it. I didn't really have access to 7 or 8 or more doors in our typical classroom in healthy times, but thankfully what you're seeing here is 7 doors from 7 different plays that had used doors with their actual sets back in healthy times. Our friends kindly got these all out of the warehouse and brought to life here me searching for the number 6. We went all out, or really our friends and artists went all out, and we didn't just put a number 6 behind the door. We put a fuzzy number 6 with googly eyes behind it as well, really just for fun and to bring this to life. Mind you, too, I was the only one really in the room, other than colleagues running our cameras and such. All of our students were actually this particular year watching online. But here you see, for instance, all of the numbers randomly ordered behind the doors. Linear search is the best you can do with this demo. We then do a subsequent demo where a colleague secretly sorts all of the numbers behind the closed doors, and then we do it again with something like binary search. Now, with this said, I don't have access to 7 doors anymore in our more traditional classroom, and so I sort of revert to just grabbing something like a whiteboard and pieces of paper and drawing with marker or chalk each of the numbers I have in mind, covering them with some Scotch tape and paper, and then treating those as the doors. So here, too, is an example of how back in the day and now do we do things really with the accessories we have on our desks and in our cabinets. This is a colleague of mine, Brian Yu, who teaches, in fact, the AI class and web class we mentioned, where he and I were not allowed to be in the same room in 2020 while teaching unmasked. But here are some plastic numbers that we found here on Amazon by searching Amazon for plastic numbers, and just to bring to life now the actual sorting of numbers. And so thanks to these shelves that we found in back, was Brian able to do something like sorting, be it with merge sort or the like, and actually give a visual to that, as opposed to just using PowerPoint or the like. In CS50, we of course use C, and C has for better or for worse, pointers and memory management. And you and I often talk about pointers in the context of addresses, or maybe even addresses on mailboxes. So it turns out when you have a prop shop, you can actually use mailboxes. So here, for instance, was a variable p representing a pointer. And when I opened up that mailbox, I found inside of it the address of some value, 0x123, for instance. Brian, in the other room, of course, had the mailbox at address 0x123. And inside of his mailbox was the value, once dereferenced, that we found. So this, I dare say, is doable on a more modest scale if you have a local Home Depot or hardware store or the like to get some inexpensive mailboxes. But this, too, was an example of just something we wanted to create memorably for students. We have another example that he and I tag team, where when we talk about variables and something simple like swapping, we typically invite a student on stage, or in this case Brian, to just swap the value of two variables. Those values in this case were represented by 2 glasses of water with some food coloring in them, so they'd stand out on camera, orange and purple in this case. And then I sort of playfully, since Brian's in on the joke, ask him to swap the 2 values. And it's not a matter of swapping the glasses. I wanted the purple liquid in the one glass and the orange liquid in the other, which of course you can't really do unless you introduce, of course, a temporary variable, at least using traditional means, and not something fancy like bitwise operations or the like. So here we had just a way of bringing to life why students, when they need to swap values, which becomes germane quickly when we start talking about sorting and moving things around an array, hopefully a memorable moment they can latch onto. We talk later in the semester about, as well, hashing. And here, for instance, is me with some jumbo playing cards, also found on Amazon as jumbo playing cards, so that they're not this big, but this big. And this is me bucketizing them literally with 4 buckets, each with a suit from a deck of cards, and me just figuring out how to hash each card into the diamonds bucket or the hearts bucket or the like, so then I can at least create 4 collections of size 13 instead of 52, and then maybe sort each of those individual buckets. I have a habit of wearing today, and really always, black t-shirts or sweaters. Well, I realized at some point that this would actually be kind of a fun way of introducing stacks, and explaining perhaps that the reason I always seem to wear black is because my stack of sweaters at home looks, of course, like this. And every time I do the wash, I just put the new sweaters back on top. And even though I own a blue and a red sweater, if you keep pushing onto the top of the stack but never exhausting the stack, you're of course going to reuse and redress in the same way. Back in the day when I in college took a course on databases, this was not done physically, but just verbally, but it stayed with me nonetheless, this idea of locking a database, be it with locks or nowadays with transactions. And so it turns out when you have colleagues who work in a prop shop, you can just ask them to bring out the old school fridge. And we use this in CS50 to talk about issues of databases and concurrency, and not wanting to have 2 different users see 2 different states of the same variable and therefore make incorrect decisions. So it turns out when you have an actual refrigerator on stage and a padlock, you can lock the refrigerator. The metaphor here being, what happens if I have a refrigerator in my home and my roommate and I both, a few minutes apart, open the fridge and realize, wait a minute, we're out of milk, close the fridge, and then go to the store. The next roommate then comes in and makes that same decision based on now misleading state, because my roommate doesn't know that I've gone to the store. So what happens? He too closes the fridge, goes to some other store. We don't bump into each other in this story. What happens then? We get back to the apartment and boom, we now have 2 gallons of milk, and that's not going to last long, and that's going to spoil before long, and so we've got a problem. But we would not have that problem if I instead locked the refrigerator, much like you might lock a table or a row in a database. And then one last visual here toward the end of the CS50 semester. We introduce students to a bit of JavaScript and a paradigm like asynchronicity and callback functions. And so this is me on an old-timey phone calling Brian, asking him like what the weather is. He didn't know when he picked up, so he hung up the phone, went outside to check the weather, and then he called me back on that old-timey phone. And I then picked up some number of seconds or minutes later, thereby demonstrating in this case the example of a callback function that's particularly germane again in the context of JavaScript. So separate from these curricular memorable moments and these demonstrations on stage, we also do a lot of live coding. And whether you've taught or not taught before, you might have a different approach to this, but I dare say it can definitely be nerve-wracking and perhaps something even to avoid. And I will say I myself rather split the difference, where I do think pedagogically there's value in doing live coding as opposed to just walking through static slides thereof. I do admittedly think there's value in screwing up in front of your room full of students, ideally in a way that you can figure it out within a few awkward seconds or minutes, but that too, of course, has value. And I do try to generally split the difference, where I, for instance, might take code like this. So for instance, I'll pull up this URL myself. If Carter, you wouldn't mind copy pasting it too. This is just an example, for instance, of what my own approach to week 1's lecture in CS50 might be. I've got a whole folder here called, by my own convention, Source 1, that just has a whole bunch of demonstrations. And these demonstrations are generally named in a way that describes what it is I want to demonstrate, not necessarily conceptually or curricularly, but functionally. Like, what does this program do, just so I and a student can find the demo they vaguely remember later as well. And I tend to do this. As you can see from this calculator example, I tend to have calculator 0, 1, 2, 3, 4, which is really a set of 5 progressions. And this is really a cue to myself that when I live code, I want to first implement for my students version 0. And then we might have a quick discussion of the same, because version 0 is usually correct, but just not very well implemented. It might be messy. It might not decompose lots of code very well. There's opportunities for improvement. And yet by checkpointing myself with then version 1, 2, 3, 4, and onward, I then sort of redo or re-live code the same. I do admittedly, behind the scenes, always have a very old school technology next to me, including right now today, which is paper. If you're curious, or if this might be helpful, just one of CS50's tools is this tool here called Render 50. There's both a command line version and a web-based version. And this is just a program that facilitates generating landscape mode, syntax highlighted PDFs of source code you've written in advance. And to this day, even though I have all this technology in front of me, this is my comfort blanket, because I can always rely on having an answer for myself or a next step, even though I do sometimes diverge from that same script. So just to give you a sense of how I personally sort of walk the line of doing live coding, but not in a way that gets me into unrecoverable problems. And the problem sets themselves. This is our nomenclature for programming assignments or homework assignments, aka problem sets. And a problem set literally might mean that. It might mean early in the semester, the problem set for students has 3 or 4 smaller problems to solve. Maybe later in the course, a problem set has just 1 problem for them to solve. But these are really just our homework assignments here. And I thought I'd share just the process by which I, and now some of my colleagues, among them Carter and Brian, go about creating these homework assignments. And in my mind, too, I have always tried to avoid using or creating problems that you might typically find at the end of like a textbook, the end of a chapter, which are fairly mundane, fairly uninspiring problems that absolutely have value when it comes to the mechanics of programming. Maybe they touch on some topic specifically. But in general, our approach in CS50 and all of our classes now has been to find some idea, some application, some domain that we can use to inspire the problem, and then use that as a pivot to the underlying implementation details that we really do want students to glean. So for instance, I think the very first problem set I wrote for CS50 back in 2007, give or take, would have been this, a program we call Mario. This is not what students implement for Mario, though, but this is a screenshot from the original Nintendo Super Mario Brothers game. But I did notice at the time, well, this is kind of an interesting pattern, this pyramid-like shape. And if you're using a language like C, or most languages that generally print on the terminal window from top to bottom, left to right, this is actually maybe a little non-trivial. It'd be a lot easier if the pyramid were this way, because then you could print 1 brick, then 2, then 3. But here you have to somehow print out all of this empty sky. So this inspires what is CS50's first problem set still to this day, which is to have students create, using C and a terminal window only, none of the colors, none of the Mario or pipe, but just pivot from this picture to implement using hashtags these individual bricks instead. Later in the class, we happen to draw some inspiration from the world of imagery, if not forensics, or steganography, the art of hiding information. And if you kind of look at your Zoom screen just right, perhaps, or tilt your laptop, you might kind of see that this isn't all just red noise with white dots as well. There's some cyan in here, some light blue, essentially, wherein there's a secret message. And so for this problem set, we have students inspired by what I remembered from my childhood being something that looked like this in a cereal box that also came with those red glasses that puts red plastic in front of your eyes that somehow reveals a secret message. So we have students in CS50 using C in this case implement the equivalent of a red filter so that when they put on those glasses metaphorically or run their now program, they see this. And if you grew up playing Clue or Cluedo, it was Professor Plum in the lounge with the candlestick this particular year. But there too, this is again a problem that really, like Mario, is maybe a couple of loops iterating from top to bottom, left or right. So some basic mechanics of procedural programming, but inspired ideally now by an idea that students can latch onto or something that just packages it in a way that inspires. Most recently, Carter and I and the team have been working on a course called CS50P, this introduction to program with Python. I'm a big fan of Seinfeld, even though the older I get, the fewer my same age students seem to know this particular show. So I'm finding new shows. But there is this scene here where Kramer, if you've watched this show, goes into a bank, and the bank's having a promotion where if you are not greeted with a hello, you receive $100 from the bank. He goes into this bank, and the teller says something like hi to him instead. Kramer demands his $100, but the banker says, no, I greeted you with hi, but hi is not hello. So some hilarity ensues. And long story short, it occurred to us, well, wait a minute, why don't we have students write a program that prompts the user via standard input for a greeting? And if that greeting starts with, is not a hello, we print out $100 they're owed. But if it starts with an H, which was the eventual compromise, they should print out $20 instead, like Kramer got. And if they print out anything else that doesn't start with an H or isn't hello, well, they get printed out $0. So here, this is actually early on in CS50P. It's really just a prompt to get input. It's an if, else kind of construct, and that's it. But here, too, we try to package it in a more fun way. And these URLs, too, will lead you to the particular specifications. There's another problem on camel case, converting between it and snake case, so to speak, to help students realize that there's different conventions out there. There's a problem set where we have students implement a very, very lightweight version of a deterministic finite automaton, a DFA, or really just a soda machine that somehow maintains state with a variable and keeps track of how much coin a user has virtually typed in order to say, yes, you're now given your Coke. Drawing inspiration from the first tweet ever on Twitter, which was this from Jack Dorsey, just setting up my Twitter, which was his nickname early on. You'll notice there's no vowels in this word. So here the pivot for us was prompt the user for input and strip out all of the values. So Twitter becomes TWTTR, but do this for any word as well. In Massachusetts, you can get a so-called vanity plate, but there's actually almost an algorithmic definition of what the rules are for what letters you can use and numbers and in what order. So we have students implement something that will validate an actual Massachusetts license plate. We have students take a look at something they might see on their car or their parents that has, of course, fractions. And we use this as an opportunity to have students type in a fraction using in Python some try and some excepts, actually parse that fraction, printing out the equivalent percentage, or if it's close enough to empty or full, E or F, respectively. There's a very popular place down the road called Felipe's Taqueria here in Cambridge that we hope, if students ever visit Boston, they might visit as well. But that's a great demonstration for now grabbing a whole bunch of menu items, like the burritos and quesadillas and others that they have on the menu, and using a Python dictionary to map those menu items to prices, giving students an opportunity now to index into a dictionary, at least in a more familiar way. I grew up with this thing here, Little Professor, which was a little device that generates pseudo-randomly mathematical formulas on the screen, like 1 plus 2, and the student has to type in the answer. But it's therefore sort of an opportunity to quiz them on math. So we have students implement a Python version thereof. We have this tradition on campus and optionally online for students where they can wear at the end of the course and be given an I took CS50 t-shirt. We tend to have some extras of these. So if you are teaching your own class in the coming year, let us know and we'll do our best to oblige with one or more of these. But we have students implement their own image generator, so that I can't do it with the green screen here, but they have to take as input a photograph, for instance, of themselves, and then overlay that t-shirt in a way that makes it look virtually like they're wearing, if prematurely, their I took CS50 t-shirt. Any of you who've used Google Forms, it turns out if you poke around with this response validation, there's a word there called regular expression that most typical users might not even know what it means, but we introduce students in CS50P to regular expressions to somehow now bring this familiar Google Form UI to students to life. And oh, that's what that now means, and just connecting it to their own real world. And then lastly, we now have not only CS50 certificates, PDFs, that we give to students, proudly congratulating them on finishing any of CS50's courses. We now playfully have a problem set where they generate, for this assignment, a PDF of a shirtificate, which says their own name virtually on the t-shirt here, and then some other text above and below. So here too, just examples along the way of some of CS50's classes wherein we try to bring fundamentals of procedural programming still, but all the more to life. And the last visuals I thought I'd share with everyone here are just now some of the course's traditions, which feed into those earlier missions of accessibility and rigor, but also generating ultimately a community among students, certainly on campus, but even now off. And some of you might know or heard me allude earlier to what we call CS50 Puzzle Day. This is an event that we hold here at Harvard in September of each year, and then online in March or April of the subsequent year for students online, wherein we give students a printed packet of puzzles, not jigsaw puzzles, but logic problems of sorts. We use this in the first week of CS50 to send the message that computer science is really about problem solving more generally. It's not about programming. And we invite students to invite their own friends, even if they've never studied computer science before. They can use laptops and Google, but no programming is needed or expected for this event. And it draws hundreds of students here on campus together, and in our case, thousands of students online. But if you follow a traditional semester where your classes might start in August or September, by all means, reach out to us after the workshop. We could provide you with the same packet of puzzles to run the event locally, or we'll also do the same on scale the subsequent spring. We end our semester with the CS50 Hackathon. I alluded to this being our 7 p.m. to 7 a.m. event, but it can be time shifted as you see fit, certainly, wherein we bring students together just more socially, more collaboratively to work on in CS50 their capstone project, their final project, which is an open-ended challenge at the end of the semester to build most any piece of software of interest, subject to the guidance of their teaching fellow or teaching assistant so that they calibrate their expectations accordingly. Of course, doing this at 7 p.m. to 7 a.m., not all students make it through the night. Among my favorite photos is this one here around 4 or 5 a.m. But at least in our case, we typically wake students up at the end of the event for pancakes as well. And then lastly, an event that we've long held both on campus and off is a so-called CS50 Fair, inspired really, but what I remember as like a middle school science fair. But at this event, we have students gather in a large space on campus, bringing their laptops at sort of bar height desks and just presenting to passersby, students, faculty, and staff alike, what it is they created for that final capstone project. And we have music and popcorn and candy in the background. We typically invite alumni or friends from industry to have their own tables and just chat with students, in our case at the university level, about full-time or summertime jobs or the like, or what computer science is like in the real world, but generally try to make it as much of a social event as it is academic so that you get expressions and interactions like these. Students not in the class, not in computer science, showing off or seeing what their computer science classmates have had. This is one of my favorite candid photos we took years ago. Clearly amazed at what he saw, but indeed that there is the goal. And in our case, and this is something we can sometimes help out with if we have spares, but offering up at the end of the semester, as you see here, the I took CS50's t-shirts that mark the end of CS50 students' experience. And along the way, suffice it to say, we at least here on campus take a lot of photos and videos. We navigate through language. We're happy to share what the requisite opt-in or opt-out language is, particularly in the K-12 level. You might need parents' blessing as well. But I would encourage you to consider, if your circumstances allow, capturing, if teaching CS50 or anything like it, as many of these moments, academic and otherwise, because it turns out, one, it's a wonderful way to look back and for your students to look back on what it is they did in your class, but it's also a wonderful mechanism for recruiting in some sense to open other students' eyes to what goes on in your or their friends' classrooms, bringing to life a fairly arcane otherwise subject like CS in a way that they might not have realized was possible. In the coming sessions today and tomorrow, you'll see glimpses of some of the lower level implementation details. Carter and Rungshin alluded to this earlier, a new tool CS50 uses called VS Code, aka Code Spaces in the Cloud. This is a tool that you'll be welcome to use in your own class. Certainly try out this weekend. It's freely available thanks to Microsoft and GitHub nowadays. You'll see a little something about how students access this tool now via the web. This, though, is consistent with my very first comment about really making the course accessible, not just in a curricular sense, but also for teachers and students who might only have Chromebooks or might have computer labs but no administrative access. Everything in CS50 can be done with just a browser these days, and you, the teachers, then needn't worry about some of those lower level details as well. For those familiar with some of CS50's prior tools, aka CS50 IDE, almost all of those features now exist in VS Code, and more are still to be ported. This is the environment that you'll soon see that provides students with a cloud-based programming environment, terminal window, file explorer, code tabs, and all. This is a built-in debugger that, thanks to Rongshin, is all the easier to use at the command line so as to step through yourself or your students code line by line. This is a VS Code extension that Brian and now Rongshin have created that allows you to implement rubber duck debugging in your own classroom. We actually have a whole lot of rubber ducks that we're happy to send out as best we can too. But barring a physical rubber duck in your classroom, you can use a virtual duck as well. The idea being pedagogically to help students hear any illogic in their thoughts. And all this too, if curious, can be done locally on students' own Macs or PCs. And for us, this is a goal at the end of the semester. We start students with a completely self-service cloud-based environment, but ultimately aspire now to offboard them at the end of the course so that they can then stand on their own, especially if this was the one and only CS course for them. And ultimately, they can now do everything locally as well. I hope you'll forgive that I'm just a few minutes after our mark. Why don't we officially end this session here? I'm happy to stick around in the same Zoom for questions, but we will officially return at 12:30 p.m., which is in 24 minutes here, for a session by Margaret on using the CS50 AP curriculum. But again, it's really also the CS50 and CS50X curriculum as well. So it's targeted not just at K-12, but really audiences younger and older alike. This, though, was CS50 Explained. Feel free to drop off, do some work, take a break. But otherwise, we'll see you again in 23 minutes here. And I'll be happy to take questions one-on-one now. See you in a bit.